All right, welcome back, everybody. This is going to be another Creative TD production. In this video, we are going to cover how to actually produce reflections. Something that I guess I kind of skipped over, but I really wanted to create a better foundation in shader writing rather than get into a lot of the more fancy effects, right? What we're going to start to do is get a little bit more of an intermediate level of shader knowledge in the coming videos and really start to develop a better understanding of how light and vectors all work together to create more realistic lighting situations, if you will. So in this particular video, what we're going to do is we're going to go and cover how to get a cube map. In this case, I have a cube map that's been created from studio type lighting, right? If something that you would use in like Mental Ray to render out a car or any sort of like product shot. So what we're going to do is we're going to make sure that this particular cube map gets rendered onto this sphere, but looks as if it's actually reflecting that particular environment map or cube map, as they're called in Unity. Okay, so it's a relatively simple process, right? But I want to show you some of the pitfalls you can work yourselves into, and just give you a better understanding of how reflections work with surface shaders inside of Unity. Okay, so in this particular scene, I've set up a nice base scene, as I usually do for these videos. And I've also gone and created a new shader, right? Just by selecting the folder and saying create new shader, okay? And what that gives you is a basic shader, right? And that's what you guys are seeing right here, okay? What we want to do is we actually want to be able to use the particular cube map here inside of our shader. So we want to be able to use this whole cube map, and we want to be able to reflect it using the surface normals of the actual model itself. Okay, so Unity provides us with a ton of great built-in functions that allows us to do this rather quickly. Okay, so let's just get through that part first. So let's go back to Mono Develop here, and to start this off, really what I want to do is I want to create a new property. All right, and this property is going to be where I actually input the cube map into our shader. Okay, so I'm going to say our cube map. Okay, and I'm going to give it the property name of underscore cube map. All right, and we are going to call this, or we're going to actually give this the type of cube, all caps. All right, that actually indicates that this is going to be a cube map, and a cube map has these 6 textures, all right, that have basically been mapped to a cube and blended together so that it creates an environment map, very similar to a probe type ambient map, okay? And I'm going to go through in a separate video and explain how you can actually create your own cube maps inside of Unity. It's really easy. It's just one of those things that isn't really well publicized or on the internet, okay? But I'll go through the creation of these and get more into maybe the artistic side of lighting by using more image-based type effects, okay? There's a whole separate part of shader writing that includes this idea of image-based lighting, and it's actually a really cool area to explore because it allows you to capture some of those more advanced effects or visual effects, I would say, that you see in a lot of AAA games. We did it on Call of Duty. We did it on Star Wars. You know, it's pretty common nowadays to use these types of effects. But before we get into those more advanced effects, I need to give you guys the foundational knowledge here of how to read these things in. So back inside of Mono Develop, we've declared a new property. All right, and this is our cube map. And I'm just going to give it an empty value for now, okay? And the second step to this process is to take this property, as you guys have seen before in all the other videos. And the new part of this is that we don't need a sampler 2D, right? The CGFX language actually provides us with another type of sampler, and that's called a sampler cube. All right, pretty easy. All right, so we're basically sampler 2Ds are for 2D textures, and sampler cubes are for cubemaps. And that basically allows us then to create the hook between this property, the input cube map that we've decided to use, allows us to pass it into our CG program here so that we can actually use this name cube map inside of our actual surface function right here. Okay, so to get this started, right, it won't work right off the bat, but to get this started, what we can do is we can say let's sample that inside of our surface shader. Okay, so what we want to do is we're going to say float 3, okay, because we just want the RGB values of this. And I'm going to call this my cube color, okay. And what we want to do is use another function that the CGFX language provides us, and that's called text cube. All right, and in this we need to give it the name of the cube map, so that's going to be cube map. And then we need to give it a vector. All right, so this vector that we're talking about is something that allows us to basically, it's really hard to describe, but basically it's not necessarily the object's normals as they are viewed in world space, right? It's more of a bent normal, and it's saying as I rotate around this, the normal itself off the model is bending outwards so that it can look more out into the environment. Hopefully that makes some sort of sense. But it is one of those things that is built into Unity. So without getting into too much of the technical terminology and more of the lower level math, I just want to give you guys a basic introduction to how to sample a cube map. Okay, so if you actually use the Unity reference manual, we can take a look here really quick, and I'll just show you where this is. So I'm going to find surface. Okay, let's go into writing surface shaders here. So you'll notice that in the surface shader input structure, so when they're talking about this input structure, they are talking about this right here, this struct, okay? This input. It says that there's all these built-in values that Unity is always basically calculating, and you're more than welcome to use these as you see fit for your shader, okay? We have used the view before, or the view direction before, but there's a ton more of these different values that are already pre-built into Unity itself. So what we're actually concerned with is this one right here, the world reflection, okay? And if you look at the description, it says will contain world reflection vector if the surface does not write to the normal. All right, this is very important, and I'll cover this in just a little bit. Okay, so what we're actually interested in now is the world reflection vector. Okay, and I'll show you exactly what this is before we see our cube map in action. Okay, so what we need to do is we actually need to put in this float3 world reflection into our input structure. So let's put that in there. So let's put that in, semicolon. Okay, I'm going to save that, and what this text cube function is, the built-in CG effects function called text cube, is expecting for the second argument is this world reflection vector. Okay, let's just put that in there. And before I actually show you the final effect, what I want to do is actually show you what the vector looks like. All right, this is a great way to start to debug your shaders, especially when you get into creating your own custom vectors. You're always going to want to see what that value actually is in a visual way. Okay, so I'm going to say float3, and we're going to say reflect vector. And this is actually going to equal in dot world ruffle. I like to say ruffle. All right, and we're actually going to have to put the same thing in here. All right, and the reason for that is because this value is actually included in our struct, our input struct, okay? And that is being input into our surface shader and is being named in. So this in variable right here, all right, contains all this information. So I need to say in.worldRefl. All right, so what I want to do is actually just see what my reflect vector looks like. Okay, so I'm going to take that and I'm going to make that just the albedo for now. So I'm going to save that. Let's go back to our shader here. Let it compile, and let's get a nice error here, and it says undefined variable text cube at line 29. Let's take a look here. And that is because text cube should not be lowercase like that. It should be cube uppercase. Let's recompile that. And there you go. And there we go. So now what we're actually looking at here, let me just go full screen, is the reflection vector. So you can see how we have an interesting kind of like rim type vector, right? Constantly, whether it's blue or green or red, right? Those values are the actual bent normals, if you will, that are looking out into the world and showing us what is supposed to be reflecting, all right? So we can actually use those directions, right? Because the vector is an actual direction in space. It's looking out, right, into a direction. So we can actually use these vectors now. So let me get out of full screen here. Inside of our shader here, so I'm going to just comment that out. So I want to actually now take my cube color and input that into the albedo. Let it compile. And there you go. So now we're actually taking this same studio cube map here that I've set up, and we're actually reflecting it. So now we're getting a true reflection, or at least what Unity has built into its CG includes to be a reflection vector. And it looks pretty good. I don't see any reason it doesn't look good. It actually looks like a real reflection, okay? And that looks pretty good. So I've actually seen this done a couple different ways, okay? So if you actually look at the Unity reference manual, they show you that the reflection should be put into the emission, and the albedo is the C.RGB, okay? And that's just fine too. We'll get a different effect. It'll be brighter. There you go. So there you go. So now you have more of a very chrome type look, right? It's very bright. So let's actually go in here. Let's put in a default, a little bit darker color there, just to kind of tone that down. So there's your basic reflection. Well, what if one of the problems that you might run into is when you start using normal maps or bump maps with surface shader. So let's start working through that. So let's first just bring in our bump map or our normal map. So I'm going to call this my normal map. And it's going to be called normal map. And we're going to make this a 2D texture. And for the time being, it's just going to equal white. Okay. So we're going to need to take this name and pass it into our CG program. So again, we're going to need a sampler 2D. Okay. And in here, what we want to do is put in the normal map. Whoops. Let me move this here for a second. We want to put in the normal map, okay? So I'm just going to use, actually I'm going to create new UVs. So I'm going to create some UVs that are specific to the bump map itself. So I can tile that independently of the main texture. All right, so now we have new UVs for our normal map. And what I want to do is just put the normal map onto my model for now, okay? And I'm also going to comment out our reflection map, or our cube map for now, just so we can see the effects of the normal map. All right. So what we want to do is we're going to come down here. We're going to say O dot, O is the surface output, okay? And we're going to say the normal is now equal to unpack normal. Okay, we're going to give it our text 2D, and we want to give that the normal map, and we want to give it these UVs. Pretty simple stuff, and there is a video that shows how to do this. So, and again, we have to pull that from our structure, our input structure. So we can say in.uv normal map. All right, and then don't forget your semicolons, and we should now have normal mapping. So this will change for a second. All right, so now if we go to our shader, it compiled just fine, and we have a new swatch here that we can actually input a normal map. So I'm just going to put in a normal map that I have, and we don't actually get any sort of normal. And that is because I put a plus sign for an equal sign. I don't know why I did that. Let's see what we get now. So there you go. So now we're perturbing the actual object normals by this normal map. So let's give this some tiling here so we can actually get some real normal mapping there. So there we go. All right. So what we want to do is let's just actually turn back on our cube map and see what happens. We get an error, and this error is telling us that there is no such field in a structure. It's a very cryptic type error, okay? And what is happening is that, well, first we can move this below our normal map, okay, and do that. But what's happening is that we're not actually able to pull in the new normals, all right? And that's because we are actually writing to the normal value of this surface shader. Okay, and let me go back to the reference manual here, and you'll notice that in world reflection it says it will contain the world reflection vector if the surface shader does not write to O.normal. Well, if you look at our shader, we are writing to O.normal. We're telling it to use these normals instead of just the object's normals, all right? So that is why we're getting these errors. Okay, so if we go back to the manual, it's saying for world reflection, you got to use the internal data comment, okay? And that says it will contain the world reflection vector if the surface shader does write to O.normal. All right, it says to get the reflection vector based on a per pixel normal map. And that's what we're doing, okay? Because in our shader, we're actually converting our lighting to a per pixel type lighting right here, because we're actually saying in our normal map, we're saying use these normals to look up the lighting, look up everything, all right? Okay, so to fix that, it's really simple actually. All we need to do is, like the reference manual says, we just need to include this statement with no semicolon. Internal data, okay? We need to do that. And then, in the last step here, you'll notice that it says, to get the reflection vector based on a per pixel normal map, use the world reflection vector with these arguments to actually pull it out, okay? So what we want to do is we want to use world reflection vector. Let's go back here. And yeah. So we want to put this right here. So instead of just using this world reflection vector straight up, we want to put in this new function that allows us to use this internal structure, or this internal data, right? Because this internal data actually includes the modified reflection vector, this one right here, with the normal mapping per pixel data, if that makes sense, right? So we want to say in, then we want to say O dot normal, right? Because we want to give it this internal data that we've modified, and then we want to say we want to base that off of the normal map, okay? Because this is now the normal map right here. All right, so now cube color should work. Save that and let it compile. All right, now we get a black shader and this awesome, very cryptic errors right here. All right, and this can be quite overwhelming if you look at it, because none of this stuff makes any sense at all. All right, and purely by trial and error, I mean, I've figured out what these things mean. So basically what's happening, okay, is that we're actually declaring this variable with this new type of normal using this new world reflection vector function before this normal is being written to, okay? And the reason why it's throwing that is because it's trying to write this using the internal data, but then it's rewriting the normal map. And so it kind of gets into this weird infinite loop, right? It's like, I don't know which one comes first, okay? So really, to fix this problem, all you need to do is actually just move this down to the emissions, down to this actual statement here, and just output the RGB of that, and we can comment this out. Oops. All right, and we'll save that. And there you go. We now have a reflection map that is using our normal map. Right, so all those, the normals, the per pixel normals, are looking up at that reflection map and are trying to figure out how they're reflecting that surface. So this is how you can get more realistic reflections. Okay, so hopefully that wasn't too confusing. It does get a little more black box, you know, when you start dealing with this internal data. But remember, anytime you write to o.normal, you have to include this internal data, right? And anything that uses this internal data needs to be declared in the variable after that normal has been written to. So usually, I like to include, or I like to write my normal function right here, or my normal variable, higher up into the shader, right? So I'll always take care of my normal mapping first, my color, my albedo, my normal map first, and my shader. And all the other effects I'll take care of last, because they are dependent on each other. All right, so hopefully that was somewhat helpful. In the next few videos, we're going to cover quite a few things. We're going to get more into image-based lighting, how to fake global illumination. I'm going to cover how to create your own another CG include type file. Excuse me. That will allow us to not have to write these surface functions anymore. So basically, our shader will become a bunch of just of these include statements or define statements and a bunch of properties, and that's it. Okay. Anyways, I appreciate you guys watching my videos, and I'm always looking at the comments, and I do appreciate all your praise. I thank you very much, and I hope you guys enjoyed this video. Thanks again. Bye.